everybody, good morning. Thank you for coming to my talk today. My name is Rosa Rodriguez. I'm a fourth year PhD student at Ohio State University under Andrea Wolf supervision in the Department of Ecology, Evolution, and Organismal Biology. And I also doing a graduate minor in statistics. Today I want to talk about the different factors that drive flower morphology evolution in Penstemon. So you probably know this, but Penstemon is the largest group of flowering plants endemic to North America. And to the left, I have a collapsed Penstemon phylogeny, the latest phylogeny. On the right, I have silhouettes of some of the Penstemon species. And we see that the blue flowers over here are shapes or silhouette of flowers that are pollinated by bees. And the orange ones over here is a silhouette from a flower that is pollinated by hummingbirds. As you can see, there is a great difference between flowers that are pollinated by bees versus those pollinated by hummingbirds. However, there is great morphological differentiation between species that are pollinated by the same group of pollinators like insects. However, Penstemon also vary on their anther shape. And here we have that there were 6 distinct flower anther morphology, and that originally the genus Penstemon was subdivided in 6 subgenera based on this anther morphology. However, recent phylogenetic studies have demonstrated that this group is now doesn't hold phylogenetically speaking because species belonging to different clades, for example, this clade over here, have this anther morphology that dihedes completely widely from tip to tip and across the connectivity. But the same anther morphology can be found almost at the end of the clade. However, even though these traits may not be phylogenetically significant, they are great traits to identify species in the field, and they may be very useful in pollination ecology. So I argue that to understand how these differences in flower morphology and in anther morphology arise in this species, in this genus, we also need to understand how these differences arise at a population level, and for that, we need to know the influences of temperature and precipitation, geographic distribution, genetic variation, flower visitors, pollinators and non-pollinators, and their effect on flower morphology. So many studies have tried to understand and study the difference in morphological variation, species that are pollinated by bees versus those pollinated by hummingbirds or birds in general. Some studies have evaluated the effect of climate, such as temperature, precipitation, snow melt, and geographic distance on flower morphological variation. Very few studies have tried to understand or evaluate how the flower can use anther adhesions and anther shape to mitigate the effect of pollen thief and how that can influence the flower morphology. And finally, none studies have evaluated how all these factors influence flower morphology together. So I'm planning to do so in Penstemon. So I have 2 main research questions. The first one is, what are the factors that influence flower morphology? And I will explore 3 sub-questions. And so how visitors, flower visitors, pollinators, and non-pollinators influence flower morphology, climate, and for that I'm going to use precipitation and temperature, and geographic distribution, and for that I'm going to use geographic distance. And the second question is how anther opening can mitigate the effect on pollen thief and how that affects the anther morphology, and I'm going to use flower visitors, again, pollinators and non-pollinator visitors. I'm going to answer these questions in 5 species of Penstemon. They're all pollinated by bees: Penstemon albidus, fruticosus, glandulosus, speciosus, and wickleyanus. They all have very distinct flower morphology, and they have really large distribution. So briefly, I'm going to explain the methodology. So to answer this question, I used flower morphology that I collected in the field, and I also took pictures of all my flowers for future flower shape analysis. I also observed anther adhesing time, so how long did the anther take to open from where the anther is completely closed to where it's fully open, fully adhesed. I also recorded and observed insect visitations in all the populations. Again, pollinator and non-pollinator visitation was recorded, and insects were identified in the lab. Further, the insects were classified into classes. And we use for that their size and their behavior. And when I say behavior, I mean whether they collect pollen or nectar, or whether they contact the stigma as well as the anthers. And finally, we collect bioclimatic variables that we extracted from the world climate. I'm going to be presenting a summary of the results based on the questions in a slide like this. So the first question is whether geographic distance has influence in the flower morphology. And for 2 of the species, the answer is yes. That means that the longitude and also the latitude have a significant effect on the flower morphology. And for 3 of these species, only the longitude has a significant effect. So here's an example of the analysis that I did to answer that question. I did a linear regression analysis where latitude or longitude were in the x-axis and corolla length and other flower traits were in the y-axis. And this line here represents the regression line. And the graph shows that for Penstemon albidus, there is a significant relationship between the latitude and corolla length, so that as you move from south to north, the flower size, in this case, the corolla length increases. Second, we wanted to understand whether pollinators have a significant effect on flower morphology. And for 3 of them, the answer is yes, they do. For 2 of them, the answer is maybe. And this is because there was an effect, but it wasn't statistically significant. We're still exploring those. Specifically for that, to answer that question, I did an order probed analysis for each species individually, and here I'm presenting the result of Penstemon albidus. And the results indicate that as the corolla mouth decreases, the probability of being mostly visited by this type of small pollen collecting bees increases. And as the corolla mouth increases, the probability of being mostly visited and pollinated by large nectar collecting bees increases. These results indicate that not only pollinators, true pollinators, but also insects that only steal flower resources but do not pollinate have a significant effect on flower morphology. The last question in this set is whether the environment has an effect on flower morphology. And here is a map of the natural distribution of Penstemon albidus in white and my sample sites in yellow, near the longitude and the latitude. And the answer for these questions using your statistical analysis is no. So after taking into account that there is a great variation in the distance between the distance of these populations, there is no environmental effect. However, this could be because I have gaps in between my sites and my sample size. I mean, I have about 10 populations, which is large, but could be not enough to actually find a significant effect. So I did find an effect, but it wasn't statistically significant. Finally, we wanted to understand whether the anther-adhesing time could mitigate the effect of those pollen thieves that, as I said before, do influence flower morphology. And we found that in anthers, for example, the one in Penstemon albidus, that adheres from tip to tip and across the connectivity, fully open, the time time it takes to fully open is much longer and significantly much longer than in anthers that open only at the tips. So we think that this morphology or this slow pollen dosage have evolved in order to mitigate the effect of pollen thief. So we know that that opens really, like that open really widely, will open really slowly, releasing pollen through time much slower than these species that is only open at the end. It's also worth to point out that we didn't find many pollen collecting bees in these species that open only at the tips, like here in Penstemon speciosus that only at the tip, and then Penstemon glandulosus that only open here at the connectivity. We didn't find a lot of pollen collecting bees. That could be because it's really hard to get pollen from here, than in comparison with these species that open widely. So in summary, we found that pollinator, but also non-pollinator visitors have a significant and strong effect on flower morphology. We found that geographic distance, but no environmental differences have a significant effect on flower morphology. We're still exploring a little bit that part. We also found that anther that digests widely takes much longer to digest, that means to fully release the pollen. We think that our results indicate that flower morphology is mostly driven by isolation by distance due to this strong geographic effect and by selection towards successful pollination and preventing pollen depletion. We're currently working on obtaining genomic data to estimate gene flow and genetic differentiation between populations. And we are also using geomorphometric data for the flower morphology to determine whether corolla shape has a significant effect on the diversification rate in Penstemon. With that, I want to thank everybody that helped me. How much time do I have? 2 minutes? Okay, I think I have enough. The Wolf Lab, James Hunt for helping me with this identification, my field assistant, there were many, I'm very grateful, and my funding for all their support. With that, thank you. So if you have any questions? Yes?
So you said that morphology is driven by these non-pollinator visitors. How do you think they're actually affecting the morphology? What would be, is this morphology effects to block them from visiting and stealing nectar, or?
Yes, so I believe, and I think that's what the data is showing, that by decreasing the opening and the flower size, they are doing two things. They are trying to prevent the visitors, but also reducing advertising, because when the flower becomes smaller, like, I will think that that will decrease their, I don't know, the advertising for come here and visit me and get my pollen. That's one of the theory behind decreasing the flower size. And that has been also demonstrated, but for pollen, for nectar thief, that when some species are mostly visited by those ants that steal nectar, they tend to decrease the flower size in order to prevent that visitation. Thank you. Yeah?
To what extent do you think that latitude and longitude reflects variation in?
We can talk later.
Yeah, okay.
Thank you.